Hello, I want to welcome you to this new tutorial. We're going to work with the Workshop 7 Parasolid solid example. Here we're going to create a solid in which we're going to have to extrude surfaces, shells, and edge blend. Then we're going to create the finite element surface and model, which we're going to analyze and post-process the results from the analysis here in Patron Astron. The first thing we want to do is create a new file in Patron. Make sure you have a file in desktop so it's easy to locate. So I have here my Workshop 7 Parasolid example, and we're gonna name this one tension underscore fitting. We're gonna click OK and wait for it to load. Now we're gonna leave this the same. We're gonna have tolerance based on model, MC natural and structural, and we're gonna click OK. So first we're gonna create the geometry of the tension fitting. We're gonna head to geometry, create, surface, XYZ. Now always make sure you have auto execute off so you don't double down on actions you have already placed. Click vector coordinates and add them as 5, 2, 0. And origin coordinate list, leave it as 0, 0, 0. And click apply. Next we're going to create points from this corner and from this corner. So first, if you want to look at the points better, you're going to select this one that increases the point size. So now you see it as blue dots. Now we're gonna go to transform, point, and translate. The same, turn auto execute off, and we're gonna change the direction vector to 0.500, which will be this new point we're gonna create here. Next, from the point list, select the right upper corner, and we're gonna click apply. And now, since we're going to move this point and create a new one here, we're going to change the direction vector to 0, 0.50. Next step is to create a curve between these 2 points. So again, we're going to go to geometry, action is now create, curve, point, 2 points. Click auto execute off. And at this point you can choose either one to be your starting and ending point. So I'm gonna select this one as my starting point and this one as my ending point. I'm gonna hit apply. And this is the general form we want to have to a surface. So we're gonna have to get rid of this portion, which we're gonna do first by creating a break. We're gonna go to edit, surface, break. Click auto execute off. And we're going to select the surface list as this one and the break curve list as this one. We're going to hit apply and we're going to hit yes. We're going to refresh the graphics, and now since these two are separate entities, we're going to delete this one. Click apply and again refresh. Now that we have our general idea of what our piece wants to be, we're going to create the solid. So again in geometry, head to create solid and extrude. Make sure you have tab meshable clicked on and then click auto execute off. Click on the translation vector and change it to 002. And now surface list, select the whole surface and click apply. Since we want to see it, we're going to click here to make an isometric view, and we're going to make it look like a shaded form and click fit to view. So this is the piece that we have, and next is to make Next, to make the shell, to make the piece, the one we want to analyze. So we're gonna head to Edit, Solid, Shell. Click Auto Execute Off and select the solid face list. For this, we can select this. We want to select these three surfaces, and to want to do that, we're gonna have to use the Shift function in order to select multiple ones. Enter 0.25 as your thickness, and again select this one, and this one, and click Apply. Next step is to create affiliates on the edges of the solid. We're gonna select only the interim ones, which is these 5 lines you see here. For this, you're gonna have to click down the middle of your mouse so you can move it freely and to select the correct lines. But first, we're gonna have to go to Edit, Solid, and instead of Method, Shell, we're gonna go to Edge Blend. Make sure you have your radius constant selected, and that it is 0.25. Again, edge for the solid selected, and click Auto Execute Off. And be very careful with this portion. You want to select these primary lines. Again, you have to hold down Shift in order to select multiple ones. And if you're certain that you already got them all, you're gonna hit Apply. And as you can see, we have all of the 5 interim surfaces with a constant radius. The next step we wanna have to do is to create the holes for the tension fitting. We're gonna create primitive solids that pass through the solid, then subtracting them in this surface. So the same in geometry, we wanna head to create solid and primitive. We're gonna select the cylindrical option, select the height as 2, radius as 0.25, we're gonna click down the Auto Execute, and now for the base point center, we're gonna enter the coordinates -1, 1.25, 1. And for the axis list, make sure you have written down coordinates 0.1. We're gonna click Apply, and there we have created our new primitive solid. Now what we're gonna do is subtract this one. So we're gonna head to Edit, Solid, and instead of Edge Blend, we're gonna go to Boolean. We're gonna click the option Subtract, click off Auto Execute. The target solid is gonna be our whole piece, so we're gonna hit solid 1. And the subtracting solid list is gonna be the one we have created just now. We're gonna hit Apply. Next step is to create the points where the 3 bottom holes will be placed by translating an existing point and then translating again. So first, we're gonna have to click on the wireframe icon. Next, we're gonna go to Geometry, Transform, and Point, and Translate. Now that we're here, we're gonna change the direction vector to 0, 0, minus 0.5. And we're gonna select the point at the edge of the fillet, which is this one. We're gonna click Apply. We're gonna make sure that it is minus 0.500, and again, we're gonna translate the point that we have just created, which is 0.37. We're gonna hit Apply. And then again, we're gonna have to create 2 more points. So we're gonna enter as a direction vector minus 1.500. But instead of the repeat count being 1, we're gonna hit 2. And as the point list, we're gonna click on the new point and click apply. Now we're gonna create the cylinders using the points as the base of the centers and then create holes by subtracting them from the solid. So the same as before, we're gonna go to create, solid, and primitive. Again, cylinders. Make sure you have turn auto execute off. And as the base center points, we're gonna select the 3 new points that we have created using the shift method. So click, hit shift, click, and click. Now that we have created, now we're going to make sure the axis list is listed as coordinate 0.2. And we're going to change some aspect of here. Make sure you have height list as -1 since we want it going down. Radius list as 0.125. And then you have turned on the cylindrical portion. And then hit apply. We're gonna go to shaded view. So now we have created this portion of the solid. Now, at the same as before, we're gonna subtract these ones. So we're gonna go to edit, solid, and boolean. Subtract. Target solid again is gonna be our main focus. And subtracting solids, we're gonna select the 3 new ones that we have created. Shift and hit apply. And there you have it. Now we want to create a point in the center of the large hole in order to create the cylinder to imprint onto the new solid. So we're gonna go to the wireframe and we're gonna go to geometry, create, point, arc center. Make sure you have auto execute off. In the curves list, we're gonna click is on the big circle in the front. This one. And hit apply. Now we're gonna create a solid and a primitive again. Create, solid, primitive. Make sure you have your height listed as 1. And the radius, we're going to have it at 0.71. 0.371, sorry. Make sure you have auto execute off. The base center point list is going to be the point we have just created, which is this one. And the axis coordinate is going to be coordinate 0.1. And we're going to hit apply. Again, we're going to go to the smooth view, which is this one. And now, for it to use the cylinder to imprint the solid and then delete it, we're going to do the following. We're going to go to edit, solid, and imprint. Solid, make sure you have auto execute off, and the solid A is going to be our main piece, and the solid to imprint is going to be the big cylinder. I'm going to hit apply. And now, to make sure it's really imprinted, we're going to delete this solid. So we're going to go to geometry, delete, solid, and we're going to click on the solid we have just created. Click apply, and refresh your graphics. And we can see the imprint is there, since it's a big circle. Now we're going to create a mesh for tension fitting. So we're going to go to meshing, create mesh, create mesh surface, and select the type as solid. Now make sure you have TED test mesh and TED10 all selected. Here we're gonna click on the input list and select the solid. Ideally, we would like to have this one at 0.25, but since this is an educational software, it will exceed our number of elements we can have. So we're going to leave the automatic calculation turned on, and we're going to hit apply. And now we can see our meshing on our tension fitting. Next step is to create the loads and restraints of the model. We're going to click on Smooth Shaded, and we're going to go to the Loads PC. You want to create a total load element and element uniform. We're going to first set the name as force, and we're going to go to input data, and we're going to select it as minus 5,000, 0, 0, and click OK. Then we're going to select application region, and we're going to select the vertical solid face created by the imprinting of the larger hole, and then we're going to click add. Click OK and click apply. There we can see our forces of minus 5,000. We're just going to change it again. Now, what we want to do now we're going to go to create displacement nodal. We're going to set the name as fixed. We're going to go to input data, and we're going to select only translations as 0, 0, 0. We're going to click OK. And as for application region, we're going to make sure you click on this space and then select the surface icon. And of course, we're going to click on the new ones we have already created using the shift method. So we're going to hit click, click, and click. We're going to add them, and we're going to click OK and apply. And there we see our fixed ones. Next step is to create the material properties. We're going to go to properties and isotropic and manual input. As material name, we're going to introduce aluminum. And input properties, we're going to have an elastic modulus of 10E6 and a Poisson ratio of 0.3. We're going to hit OK, and we're going to hit apply. Next step is to create the 3D element properties for the tension fitting. So we're going to go to properties, create 3D and solid, which is here. And as property set name, we're going to enter 3D test. We're going to go to input properties, and we're going to select the material we just created, which is aluminum. and click OK. In application region, we're going to select the members, and we're going to select the entire solid by dragging a box around it and clicking Add. We're going to hit OK, and we're going to hit Apply. Now we want to check the load case default to make sure that the load and constraint are selected. So we're going to go to load case, we're going to go to modify, and we're going to go to default. Here we can see the two forces, fixed and force, and they're both entered. And we're going to hit cancel to go back. Finally, we're going to have to run the analysis with MSynastron. So we're going to go to the Analysis tab and wait for it to load. Here we're going to select Analysis, Entire Model, and Full Run. Make sure you have as translations parameters. Here you can select either or small. We're going to leave it as either. Solution type, make sure you have linear statistic and you have 101. And as for the output formats, make sure you have your XDB and your print turned on. We're going to click OK, OK, and OK. And finally, we're going to hit Apply for it to run. Next is to attach the XDB file and access the results. We're going to go to the XDB. We're going to go to select results file, and here we have the one we have already called for. We're going to select it and we're going to hit apply. Here we can see that the attached result file has already ended, so we're going to go to the results tab. We're going to create a deformation plot by going to the results, create, and deformation. And we're going to select displacements transitional. We're going to hit apply. And now to erase the geometry, and since we don't want to see the undeformed model, we're going to have to show only the deformed model. So we're going to go to display, in this part, plot erase. We're going to erase the geometry. We're going to hit OK. We're going to go to the display attributes. We're going to remove the show undeformed, and we're going to hit apply. And we're going to go to the shaded view. Hit apply again. So at this point we can see our entire tension fitting as it is, with the deformed loads. Now we're going to create a plot for the bond mesostress for the model. Same as before, we're going to go to the results, create fringe. Make sure you have default A1 static subcase turned on, and we're going to go to the stress tensor. Next, we're going to select display, attributes again, and then set display to element edges only. And hit apply. And there you have it. You have now completed workshop 7. Thank you for your attention.